We will now see an example of how to simplify a given function using K-map and then implement the simplified function using the two combinations, any logic gate or by NAND only. The given function is f equal to sigma m 0, 2, 4, 6, 8, 13, 14. So our first step is to find out what are the number of variables of the function. Highest term is 14. 14 will be represented by 1, 1, 1, 0. This is 14. So we need 4 variables A, B, C, D. So we have seen that this function f is a function of 4 input variables A, B, C, D. So we come to know that the K-map drawn will be a 4 variable K-map. AB are the MSBs. So AB will be on this side. A bar, B bar, A bar, B, AB, AB bar. The next two functions are CD. They will go on this side. AB was on the vertical side. So we start with C bar, D bar, C bar, D, C, D, CD bar. Our next step is to number the squares 0, 1, 2, 3, 4, 5, 6, 7. Leave this 8, 9, 10, 11, 12, 13, 14, 15. Now this is a sigma function. So we know that sigma terms value is 1. So what we do is put a value of 1 in the sigma squares of 0, 2, 4. Let's do it. So 0 is a 1, 2 is a 1, 4 is a 1, 6 is a 1, 8 is a 1, 13 and 14. The remaining squares will be filled with zeros. So this is the first step of filling the K-map. After filling the K-map, now our next step is to group the ones. And what are we trying to find? Either a pair of 2 ones or a quad of 4 ones or octet of 8 ones. Start with the highest group. Let us try to find 8 ones. Do we see any 8 ones here? No, we don't. So next, let us try to find 4 ones. Vertically 1, 1, 1, this is a 0. So we can't do like this. See carefully, you have 1, 1 over here and a 1, 1 over here. The K-map can be folded vertically. So this square 2 and 6 can be grouped with 0 and 4 from this side, and both these will now form a quad. 2, 6, 0, 4. This quad of 0, 4, 2, 6. This forms a quad because these are adjacent neighbors. Okay, what are we left with? Any one left? Yes, this is a 1 here. This one, there is no one near. Diagonally you cannot group, horizontal or vertical. There is no 1 here, so we cannot group it. See, you can find a 1 over here. So there is a 1, this one from this side and this one from this side. This and this. These both form a pair. So this is 8 and 0. So 0 and 8 form a pair. 1, 1. Any one left? Yes, we are left with this one yet. This one, if you see carefully, has a neighbor here. So it can be paired like this, and this becomes another pair. What else is left? This one is left. This one has no 1. There is no 1 next to it. So it will be left as a single. We will call this as a single. Anything left over here? All the ones are covered? Yes. So we may say that you have completed your grouping And what we saw was that there is one single, then this pair here, this pair here. There are two pairs, one single, two pairs, and one quad. So there are one single, two pairs, and one quad. So we have 2, 3, 4 terms in this function. Let us try to find the value of each of these. Finding the value for each of them, let's do it one by one. Let's see the value of this pair. This pair will be, how do we find the value? We have to see the row and the column. So for this, the column is C bar D bar. Single column, so it will be C bar D bar. And the row is A B bar and A bar B bar. Compare both of these. You find that B bar is same, A is changing. So A is eliminated and you're left with B bar. So B bar, C bar, D bar is the value for this pair. And did you notice one variable is eliminated? A is eliminated. Now let us see the value for this pair. This pair has the column as CD bar. So CD bar. And from the rows, you have A bar B, AB. Compare these two. B is common, A is changing. So changing is eliminated. Common, you're left with B. So the value of this pair is B, C, D bar. Now let's see the value of this quad. We remember that quad has to eliminate two variables. Rows, columns. For this quad of 2, 6, 0, 4. Rows are these two, this and this. From the row, the common is A bar, eliminated is B. So you're left with A bar from this side. A bar, B bar, A bar, B. Okay. Column, these two columns. So the column is CD bar and C bar, D bar. If you compare these two, C is changing, D bar is common, so you have D bar. So the value of this quad is A bar, D bar, and note that two variables have been eliminated, B and C. What are we left with now? This single. We have to write the value for this single, and that value will be written from the row and the column. Single means no variable will be eliminated. So we have the row variables AB, and from the column we have C bar D. All the values having been solved, we can finally write the solved function as f equal to. What is f? What have we finally found? The simplified SOP. The simplified SOP f is equal to, we just add all of these, the single, the two pairs and the quad. The single is, let's start with the single, A, B, C bar D. A, B, C bar D plus the two pairs. The pair is B, C, D bar, B, C, D bar plus the other pair is B bar, C bar, D bar. D bar, C bar, D bar plus the quad is A bar, D bar. So having written the function like this gives you the solution for the simplified function f with the help of K-maps. So this is how the simplified function can be obtained from the K-map by the groupings. In the next video, we will see how to implement this with the help of logic gates and by using only the NAND and the NAND gates. Simplified SOP function. Thank you.